Math 3 Polynomial Test Review. Alright, so we will take a look, go over each of these and see what we can get from it. So, first thing is the division. Okay, now remember we can use that synthetic division to help us out with that. So the way we do that, you take that and it's the opposite, so plus 2 would be negative 2. That's the one you put in the little box. Okay. Then we take the coefficients of each of them. So our highest degree was a 3. So I'm going to start with the coefficient 3, then negative 2, then I need more space, don't I? So let's go right here. So negative 2, coefficient of 3, negative 2, negative 23, and negative 7. So x cubed, x squared, x to the first, x, no x. Okay, so we're in line, we don't need to add any extras, which sometimes we'll do. Then remember, you take the first one down, then multiply, bring that up here. Negative 2 plus negative 6 is negative 8. Negative 2 times negative 8 is positive 16. Negative 23 plus 16 is going to be a negative 7. Negative 2 times negative 7 gives us a positive 14. Add those together and we get 7. So then remember, when you divide, you have to write the answer as a function, this depressed function. So 3 is our coefficient for the next power, right? We divided an x out of 3, so we take it down to x squared, then negative 8x, then minus 7. Then when the remainder is not 0, remember, if the remainder were 0, then that would indicate that we have a factor here. This one is not. So we go plus 7 over x plus 2. That's our remainder, and it has to be tacked on there to the end. Okay, so that's how we use synthetic division. So we'll do it for number 2 as well. So now this is r plus 3, so it's a negative 3. If it were r minus 3, then in that box we'd put a positive 3. Okay, so I have a coefficient of 1, negative 7, negative 20, and positive 37. Bring the first down, times negative 3 comes up here, add them, we get negative 10, positive 30, add them, we get negative 10 again, or no, positive 10 this time, and then we get a negative 30, so positive 7 again. So we go depressed, so we'd go 1r squared minus 10r plus 10 plus 7 over r plus 3. And that's how we use that synthetic division. Remember, we usually use it to help us with factors. Okay? Alright, number 3. Now number 3 just wants us to look at what the possible number of zeros or roots or x-intercepts are. Remember, we have that fundamental theorem of algebra, which is if you take the highest degree, which would be 5, that's how many zeros you have. So that's our answer. 5 zeros. Now, remember, you could have 5 real with rational and irrational. You could have 3 real and 2 imaginary. Remember, those imaginary always come in pairs. Okay. You could also have 1 real and 4 imaginary. But all I wanted you to do was do the 5 zeros, but just reminding you about that. Okay. So number 4, the highest power is 10, so we have 10 zeros. And that's all we had to do on those ones. Okay? Alright, now we're going to find the zeros. Now if they're in the factored form, we like that. That's easy, right? That one we can deal with. So we would go 2x minus 1 equals 0, and x minus 1 equals 0. Then we solve for x. So 2x equals 1, divide by 2, we get x equals 1/2. Then we'd add 1 to x equals 1. Now, remember that number out, if it's outside the parentheses, that's your multiplicity. So my x's would be negative, or 1/2, and 1 with a multiplicity of 2. So 3 zeros, right? 1x and 2 x's would be a degree of 3, so 3 zeros. 2 right there, 1 right there. Okay? Now, if x is just by itself, that's 0. Then I've got a 2x plus 1, so solve for that one. we get 2x equals negative 1 divided by 2. We get x equals negative 1/2. So 0, negative 1/2, and then x minus 1 would give us a positive 1, wouldn't it? And they all have a multiplicity of 1 because there's no powers raised to them. Okay, those ones are easy. Now, how do we deal with 7, 8, 9, and 10? Okay, a few things we can do. We can use the calculator to help us out, or we can graph them. Graphing them helps if we find real roots, but doesn't help if we have imaginary roots. Okay, so just really quickly, I'm going to show you how we put in our answers. Okay, because we'll want to use the calculator for this. So that's pretty much the easiest way to go about this. Now, we could do that whole thing that we learned where we find how many what the possible real zeros could be, where we take the factors of the coefficient over the factors of the constant over the factors of the coefficient. We make fractions, so 1 over 1 and 1 over 2. So 1 could be a real answer, or 1/2. Then we use the synthetic division, right, for both of those. So 2, negative 1, negative 2, and positive 1. And then we figure it out. We go 2, multiply, that gives us 2. 1, multiply, that gives us 1. Negative 1, multiply, that gives us negative 1, 0. So that tells us that 1 here is a real root. So x would equal 1. And then that would give us the depressed, so that would be 2x squared plus 1x minus 1, and that 0 leaves there. Then we'd factor this further, and we'd say 2 times 1 is 2. Factors of 2 that add up to 1, positive 1. Can't do that, I don't think, so let's do the quadratic formula, right? So the opposite of b plus or minus the square root of b squared minus 4 times a times c over 2 times a. And then we simplify that. So negative 1 plus or minus square root of 1 minus 4 times 2 is 8 times negative 8. That would make a plus. So we'd get negative 1 plus or minus the square root of 9 over 4. We know the square root of 9 is 3, so negative 1 plus or minus 3 over 4. So negative 1 plus 3 would be 2 over 4. Negative 1 minus 3 would be negative 4 over 4. So we'd end up having 1/2, 2 over 4, and then negative 1. So they actually end up all being reals. So yeah, you could do it that way. Now, that one worked out really easily. Usually they don't. So that's why I would say that's the last thing you want to do. Okay. Number 8, you could have graphed as well, and we would have got that information right? Your graph would have looked something like this. So 1, negative 1, and 1/2, we have zeros. And it would have looked something like this. And you would have been able to tell on the graph all those zeros. Okay? So, let's take a look at this one. And I'm going to go to an empty page now. So, we've got f of x equals 3x to the 4th plus 26x squared plus 48. So remember, in the calculator, you can either go to graph or to new document. I prefer new document. You can start by adding a calculator. Then you type in your equation right there, right? And then hit enter. Okay, if you need any powers, right, you use that to make the powers. Variables, negatives, plus or minus, all that stuff right there. Then, once you type it in, you hit enter, and this is what it gives us. Now, here's the problem. Now, the problem with graphing is this one, as we can see, it doesn't cross the x-axis, so it has no real zeros. They're all imaginary. So there's no way we can use synthetic division or anything like that to do it. Now, it may not have shown up at first, and remember, if you hit menu up here, and then go down to window and trace, you can zoom out or change the window settings. Okay. Now, what we like to see is if we graph another one now. I graphed this red one. Okay, that's question number That's number 9. Okay? So see, when we graph that one, we can see there's zeros right here and right here. And we can also see that one has an odd multiplicity. This one, because it bounces, have an even multiplicity. Well, the highest degree is 3, so pretty easily we can see a multiplicity of 1 and a multiplicity of 2 would get us our 3 roots. So we have them right there. We don't need to do anything else. Now, if we want to know exactly what they are, you hit Menu again, go to Analyze Graph, hit 0, click on your graph, choose a lower bound and upper bound, and we can see we can get them both here, so we have that answer. So x equals -3 and +1 with a multiplicity of 2. Okay? But it didn't work out so well in the other one. So remember, there's another way we can do this. If we open up a calculator, and we'll use this example to help us with that, number 10. Okay? Alright, that is number 10. Yeah, so we'll look at that one. So by using number 10, okay, if we click Menu and go down here, it says Algebra, click on that, then we go down to Polynomial Tools, and we can click on Find Roots of Polynomials. So you put your degree in, so I put in our degree of 5. Then we always want to choose complex. If you hit OK, it'll give you this list. So you start with the first coefficient, and you just work your way down to the constant, entering in those coefficients. Hit OK. Then it'll give you this. You hit Enter, and then it'll give you your roots. Okay. Now the problem with these roots is that they're decimal format. But if you were to try to answer this question here, they wouldn't be in decimal format. So what you can do on a multiple choice question, for me I'm fine with the decimals, but on multiple choice, just type in these numbers and see which ones match up with your decimals. Okay. Now we should have 5 zeros, so we have that decimal, which is real. We have that imaginary, positive and negative, so there's 1 real, 2 imaginary. Then I believe we have this one, the positive version of that irrational real one, and then 3, another real one. So 1, 2, 3, 4, 2 imaginary, 3 real, which if we were to give a multiple choice would look like that. So the square root of 6, I square roots of 6 would be one of those guys. Okay? So that's what you have to be careful of. But there you go. There's the answer for number 10. That's what it would look like using the calculator. That calculator can help you out. Okay? So if we go back to this one, we know they're all imaginary. So once again, we can use that same thing. Now here's one thing I wanted to note. We have a degree 4 and then a power 2. We don't have an x cubed, so we think of it as 0. We don't have an x, so we think of it as 0. So notice I had to put a 4th degree, but on a couple of those I had to put 0 in as their coefficient. Don't forget about that. You hit OK, hit Enter, and then we end up with our 4 imaginary roots right there. Okay? So that should take care of all those ones. Now let's talk about some end behavior. So, end behavior. Remember, we've got the degree that figures into end behavior, whether it is even or odd. And then we also have the leading coefficient that figures into end behavior, whether it's positive or negative. So, even positive, they both go up. Even negative, they both go down. And with odd positive, the right side goes up, the left side goes down. And odd negative, left side goes up, the right side goes down. Now, the way we're going to write it is something like this. As x approaches infinity, so that means as we look to the right, our function does something. What does it do? And then as x approaches negative infinity, so as we go to the left, what is our function doing? Is it going up or down, or left or right? And we can put equal sign, or we can put arrows. We can even switch them around in order. Okay? But you do need both parts. You need just the regular x and the f of x. So, this one, number 11, positive, even power, negative. So even negative, they both go down. So so they both go down to negative infinity. Okay? For number 12, let's write it up here. So let's show that you can do it backwards. F of x does what as x approaches positive infinity to the right and as x approaches negative infinity to the left. Okay, so 12, we've got an odd and a positive. So odd positive, oh, wrong one. As we go right, we go up. So as we go to the right, we go up. And as we go left, we go down. So as we go to negative infinity, we go to negative infinity. Okay? Now 13 and 14 want you to sketch the general shape of the function. Okay? So it's still basically that same concept. Okay? So let me clear off some space. So let's look at the degree. 13 has a degree of 4, so that's even, positive, so we know they're both going up. Okay? It's a degree of 4, so it should have 4 zeros. Some could be imaginary, some could be real. I'm just going to pretend they're all real for my basic shape and make it go something like this. Cross through all those and that end behavior. Okay, for 14, we've got a negative odd, right? That 5 is odd and negative. So as we go left, we go down. As we go right, we go... Oh no, wrong way. As we go left, we go up. As we go right, we go down. So I draw my graph. There's 5 roots. So I could put all 5 of them in there if I wanted to. And I'd start up here. And do something like that. Okay? Basic shape. So the main things you need to understand is these, the end behavior. In the middle, if you can follow that, but I mean with imaginary roots, it may not look exactly like that either. But that should be good enough. Alright, now identifying the solutions for each system below. So where do they intersect? They intersect here and here. So that one's easy. The point is 2, 0. This one's a little tougher because we're going to have to guess at it. It's not quite halfway, so maybe we'd go negative 3.75 maybe. And then it's not quite to 36, but we're counting by 4s here, so we could probably call that 35. Something like that. You just find where they intersect. What's that point? Those are your solutions. Now, if you don't have it, you just graph the points. Okay? And you find where they intersect. So we can see as we graph these that they're going to cross 3 times. Here, there's our first answer. Here, second. And here, our third answer. And that's what you write down. So whether you use the Desmos or graphing calculator, you can pretty easily see where they're going to intersect and use the calculator to help you find that. Alright, so now looking at the last 2, we are dealing with drawing a graph, talking about the degree, talking about everything that we have going on. Okay? Alright, so the first thing we need to decide is the degree. So look at the x's. I've got a square, to the first, no other powers. So 2 plus 2 plus 1 plus 1 would give us a degree of 6. So my end behavior, which I can write like this, okay, for left and right, or I can write like this, the limit as x approaches infinity of f of x equals, you just got to make sure you have both parts, the left and the right, right? And it can go up and down. So it's even. Then we look in front, it's positive. So it's even and a positive, which means they're both going to go up, which we call infinity. So I either write it like that, or I write it like that, doesn't matter. Then we need to find the zeros. So we should be able to see that we have a positive 1 for a 0. And all of these, because they don't have powers outside of the parentheses, have a multiplicity of 1. So I'll just go like that. Okay, we've also got a plus 3, which becomes a negative 3, 0. Then x squared minus 9, right, if we set it equal to 0, to solve for x, we'd take the square root, so we'd get a positive and a negative version of 3. So we already have a negative version of 3, so I take that back. We do have a different multiplicity, don't we? Because even though they didn't have that squared, had we simplified this, we could have put a squared there. So instead of writing negative 3 twice, we have that multiplicity of 2. Okay? And then we also have a positive 3. Then for x squared minus 4, hopefully you can see that one already. Add 4. We get x squared equals 4. Take the square root. Square root of 4 is 2. Positive and negative. So we have a negative 2 and a positive 2. All of those ones have a multiplicity of 1. Now we graph it. So we've got a 0 at 1, negative 3, positive 3, negative 2, positive 2. Now, our and behavior is both going up, so the furthest right, 0, and the furthest left, we know, are both going up. Okay? Then we look, what are crossing? All these ones are crossing, the only one that's touching is negative 3. So that one's going to bounce up, then I'll have to come back down and cross, come back through and cross through the rest, and we get something like that. Okay? There we go with that one. Now, looking at our last problem. Okay, once again, let's count the x's. There's 1, but there's actually 4. So we go 4, 2, which would be 6, and 1 more would be a degree of 7. Okay? And we look in front, it's positive. So odd positive, remember, to the right goes up, to the left goes down. So I write the limit as x approaches the right of my function, it's going up. The limit as x approaches the left of my function goes down. Okay, make sure you pay attention and do both of them. Or as x approaches negative infinity and as x approaches positive infinity, f of x approaches negative infinity or positive infinity. You could even write a f of x as f of x approaches negative infinity as x approaches negative infinity. You could even flip it around and just take those and move them out to the front. But you only need 2 of them, okay? You only need 2 of them. Now we look at our zeros. So there's no squares inside the x's, so I know that's a positive 1, positive 2, negative 4. So negative 4, 1, and 2. Now negative 4 has a multiplicity of 4. It's even, so it's going to touch. Positive 2 has a multiplicity of 2, so it's going to touch. And 1 has a multiplicity of 1, so it'll cross. So we have a 4, a 2, negative 4, negative 4. Negative 4, a 2, and a 1. Now I know from this furthest point, I'm going to go up to the right. Okay. I also know it's going to bounce, so I can kind of bounce it up. As I go from this point to the left, I'm going to have to go down. So I know this one's going to be coming, and negative 4 is also going to bounce. And then it comes back through, and 1's going to cross, so it'll look something like that. Okay? So, if you guys got that all mastered, make sure you have some good notes to take with you to help out, and you should be ready for the test.